Going live now.
All right, hello, I think I'm live now. So this presentation is on the road to Cosmos SDK v1.0. I'm Aaron Craelius, I'm the CTO of Regen Network. And before I get into the Cosmos SDK, I'll just give a little intro to Regen Network. We are launching a Cosmos zone dedicated to ecological applications. So you can think of carbon credits and beyond. And since April 2020, we are acting as the lead maintainer of the Cosmos SDK. Cool, and I see people dropping chats in here. Great, so if you have questions, I will probably not be monitoring the chat until I get through the presentation. So kind of, put your questions there, but then I'll come and, get to them once I get through the slides. So the first question is, what does 1.0 even mean? And so, the first answer is 1.0 is a commitment to stability. And so maybe it's obvious, but why is stability important? The theory we have is we can't really build durable, long-lived systems without stability. We need a solid foundation to start building other layers. So if we, like with the internet, if we have a basic guarantee that things like TCP, IP, and HTTP are going to work, and yes, they'll be improved, but that things that we build on top of those will be stable, then we can start building other layers on top of it and lots of interesting things. The other answer we have is that 1.0 is a commitment to a great developer experience. So the idea that we're going to work out the whatever kinks there are in using the Cosmos SDK as a developer before we get to 1.0, so that what we launch as 1.0 is something that we really feel great about going forward. And so why is developer experience important? Blockchain is hard, and a successful blockchain development platform must have a strong focus on developer experience to balance against the inherent complexity of developing distributed ledger technologies. So we want to sort of have our framework, the Cosmos SDK, take away as many of the hard parts as possible so that you can just focus on writing the software you're trying to write and getting it correct, and getting something out there that users can use and build amazing things with. Okay, so the next question I want to put there is who are we trying to achieve stability and good developer experience for? And I want to talk through three different user kind of groups that I'm considering for the Cosmos SDK. And one are client developers. And so these are developers building user-facing apps that integrate with Cosmos SDK blockchain. So these are your wallets and block explorers, but hopefully, many other apps. Regen is building a registry for carbon credits and other ecosystem service credits. People are thinking of all sorts of amazing things like, decentralized Twitter and social media, all kinds of DeFi kind of apps. So client developers are one, really important category because they're, the closest to the users. Module developers, these are developers building custom modules for Cosmos SDK blockchains. And, module developers are also core SDK developers that are writing things like the bank, the governance, staking modules, etc. But, part of the vision for the Cosmos SDK is there's going to be a thriving ecosystem of third-party modules that are building on top of the SDK, and that these can be composable. And actually recently, one of the developers of the SDK, Bez, launched a module kind of browser called Atlas. So, we really want to consider these module developers so that they can build great modules that people can use to compose Cosmos SDK blockchains. And so the final category I'm calling app developers. And these are developers that are building, the actual blockchain. Like, for instance, Regen Network, when we're launching our blockchain, we're an app developer. Other projects that are out there like Kava, Akash, etc., app developers. They may also be module developers and writing their own custom modules. But when it's just a matter of let's pick these modules off the shelf, we have Gov, banking, etc. That's what I'm calling an app developer. So one of the big things that we've been focused on, that the Regen team has been focused on since we started working on the SDK seriously, is the Stargate release v1.0, which cross our fingers is just around the corner. We've been in the release candidate phase for a few months. We think the actual release may be happening hopefully within a week. So I want to touch on two ways that I think Stargate moved us closer to 1.0. One of the big things about Stargate is IBC, but I'm actually not talking so much about IBC here because I'm focused on sort of the core aspects of the SDK that are moving us towards like that stable foundation layer. And so one of those is protobuf, which is a standard multi-platform protocol for clients. And then another is live upgrades. Basically with live upgrades, blockchains can gracefully upgrade, in a coordinated fashion, replacing one binary with another binary at the correct height and running migrations that are needed from one version to another version without needing to start over from Genesis, like currently has to happen with the Cosmos Hub, where there's Cosmos Hub 1 and 2 and 3 and 4. Hopefully, eventually, the idea once we do the Stargate upgrade is that eventually the hub can just start upgrading at such and such height, and then maybe there's a couple minutes of downtime, but things more or less just continue in a linear fashion from there. So I want to talk about some different ways that I think Stargate improved the developer experience for these different user groups and moved us closer to 1.0. So for module developers, I think there's a greatly simplified workflow for implementing a module, which is first you write the proto definitions, then you generate some code, then you implement the interfaces that the generated code produces, and then you wire up the services that these interfaces kind of represent in a single register services entry point. And I'll walk you through these 4 steps with some code samples. So first we're writing some proto definitions. And so this is actually right out of the SDK, the message service for the bank module. And for those of you that aren't familiar with the SDK, we use the kind of MSG message abbreviation to mean some sort of message or operation that's going to end up in a transaction. So that lingo might be a little confusing if you're not super familiar with the SDK. But you can think of message as kind of like a transaction type thing. And here we're using these protobuf service definitions, which actually let us define a request type and a response type. So now, when we're sending messages and transactions, we also have a typed response. So for sending coins, there is no really information in the response message, but for other messages like creating a proposal, like creating a governance proposal, there would be like a proposal ID that's returned. And, there are lots of other uses for that. Okay, and so this generates, one cool thing is that this service generates this Golang interface that we can then just implement. We just need to implement these methods, and then we just wire it up in a single register services call. And it should be a pretty straightforward path to, like, you define this service, you define it for both for the message transaction side and the query side, implement those services, register them, and boom, you should have a working module. And there's obviously other stuff to do like Genesis and CLI clients, but the core stuff can be done with just this infrastructure that I've shown here. So I think that's a big step up in kind of the module developer user experience, and people from our team have, felt that that's the case when we've started implementing some of our custom modules for Regen. So for client developers, I think there's also a greatly improved developer experience story. Maybe this is the kind of biggest improvement. So for one, we can have client libraries in all languages because protobuf basically has an implementation in every notable language out there. And together with this, we have sort of the promise of backwards compatible APIs. We have a tool, a breaking change detector tool that gets run in CI every time there's a commit. that prevents breaking changes in V1 protofiles. So what this means is that once we kind of release a V1 for the bank module or the staking module, we will be able to upgrade that API and add new features, but clients will not break when we add new features. There'll be backwards compatibility. We're not quite there yet, but we released the modules in Stargate as V1 Beta 1 because we want to put this out into users' hands and just make sure we have some of the core assumptions correct. But the goal is to get to V1 pretty quickly, and I'll talk about that in a bit. Another thing is we're using gRPC. So you can use gRPC kind of as a single protocol for talking with all the services in a Cosmos SDK blockchain, or you could alternatively use a REST API, and actually our protobuf files automatically generate a REST API with Open API or Swagger definitions. And then another thing I want to note is that the transaction signing for protobuf signing is pretty straightforward to implement given any off-the-shelf protobuf library. So, basically, if you have a protobuf library, maybe it's an additional 20 lines of code to kind of get signing working for all message types. You don't need to know, there's no kind of extra things in addition to that, at least for the most basic sign mode direct protobuf signing. And so here's an example of TypeScript generated code for that bank message service that I showed. So and this is, exactly what gets generated. And most clients will end up with, some code that is pretty straightforward, that is basically just what's in the protofiles, and it will show up in all, basically all languages. And here's a screenshot of the automatically generated REST Open API endpoints, which, are a direct mapping of what's in the protobuf files. So there should be a pretty good developer experience going forward with this system. At least that's our hope. So I want to say a word about Stargate for app developers. I don't think we made big improvements in that area, and I think maybe we even made things a bit worse. And this is just a screenshot of the part of app.go in SimApp that I could show, just showing part of the import. So, the import list itself is maybe 100 lines of code, and then there's a lot of wiring. And this is one thing we really want to improve upon for 1.0. So, Stargate was about setting a foundation, but there's a lot of work to do. All right, so what are some of our 1.0 goals for client developers with respect to kind of protobuf? Because there's still a few things we, need to do to kind of provide the full experience we want to. So one is, like I said, we want to stabilize the protofiles as V1. Right now, they're mostly marked as V1 Beta 1. We want to mark them as V1 as soon as we can, once we feel comfortable with those, so that we can provide that promise, that commitment to client developers that you can write client apps against these protofiles and these modules, and you can expect a long lifetime of, basically not needing to update your app unless you want to support new features. And you won't have to kind of be constantly on the lookout for breakage every time there's an upgrade to a Cosmos SDK chain, like the hub. So it's likely that we will actually move the protofiles to V1 before the SDK itself reaches V1. We say that as kind of like the first step. We'll first, kind of commit to those protofiles, and then we'll kind of work on other parts of the SDK before calling it a V1. Another important area for client developers is there's some more things we have to do around transactions. In particular, we need to implement what's called sign mode textual to replace amino.json. So the kind of legacy signing mode, which uses the amino.json serialization, is still mostly supported in Stargate, although IBC isn't supported at all. And it's needed for the Ledger app, which kind of parses that JSON and prints some human readable things to users. So the idea is that we want to have a protobuf-based textual signing mode that the Ledger app and other hardware wallets can use to show kind of human readable text in a format that's really easy for like a small microcontroller like a Ledger to parse. We want to improve the multi-sig signing UX. So there were maybe some overly cautious things we did when we designed Sign Mode Direct. We were kind of aware about it at the time, but weren't able to reach any consensus on the best way forward. So currently, if you're using a multi-sig wallet using Gaia CLI, that still is using AminoJSON signing, and we want to work on making that multi-sig signing experience, good with protobuf. We are also working on a standardized public key address format for new signature algorithms. So that's something that has been kind of in process for a while. We're going to be consulting with a professional cryptographer next week, and hopefully we have kind of something we feel good about for extending the number of signature algorithms in the SDK. Okay. And now I want to talk about 1.0 goals for module developers. So for module developers, there's some things with the generated protobuf code that are less than ideal. It's we are encoding Golang interfaces as any's in the protobuf code, and the workflow for using any's is a bit clunky. Hopefully we can do better if we did some custom code generation. There's also some issues with custom types, and we could possibly make those service interfaces that I showed you before maybe a bit more ergonomic for module developers. One of the things that we're wrestling with in terms of protobuf is that when we first started migrating the SDK to protobuf, we decided to use a library GoGo protobuf, which at the time was kind of the the best and the fastest Golang protobuf library. And a couple months later, Google announced their own V2 protobuf library, which is incompatible with GoGo protobuf. And sort of we've kind of been in this space for the past year, trying to figure out what is the path forward. So we're going to have to kind of wrestle with that in the next year. We want to simplify and stabilize before we get to 1.0, we want to simplify and stabilize the core types package. There's a bunch of things that probably don't belong there. One other thing is we've noted that we need to provide some better basic decimal support as part of the core types package. And there's a lot of other kind of, I think, API cleanup issues we could do, not just in the types package, but like in the client package and some of the other kind of core base packages, which aren't really part of any module, but which all modules depend upon. And we also want to simplify and improve the app module interface and intermodule wiring. And so, yeah, I'll say a bit more about this intermodule wiring in a bit, but I think that we have some interesting ideas based on the Stargate work about how we can improve the way modules talk to each other. And we think this could help dramatically simplify app.go. And I'll get into that in a minute. And then the other thing is we want to remove a lot of the legacy code, which is already deprecated, just so that there's not kind of cruft hanging around that we don't want to be supporting anymore. So, all right, a bit more on this intermodule communication. I showed you the message server interface that protobuf generates. The protobuf compiler also generates this client interface, which is pretty similar. And this is the interface that you would use to build transactions, and so or to make queries. Slightly different process that for transactions and queries, which I don't want to get into, but the basic idea is that there's this interface generated, and there's also kind of some basic implementations of these interfaces that are generated, and we could use these interfaces for modules to talk to other modules. So Currently, there's some pure Golang interfaces defined, which are the keeper interfaces in the SDK. A couple of things that are this is sort of a pretty big issue that I don't have time to go into fully, but a couple of the things that are problematic about the current keeper interfaces is that there's not really kind of explicit authorization. So sometimes there are things that are exposed that we might want to encapsulate better. Also, if there's changes to those interfaces, generally all the parameters are positional parameters as opposed to these structs, and it's generally easier to add fields to structs than to add more positional parameters. And then another kind of issue that has come up is that there sort of needs to be some atomicity between calling another module and either committing the changes to the store or reverting those changes. And so using these kind of client interfaces with a sort of like intermodular router could let us take care of authorization and atomic calls between modules. And like I said, we think this could greatly simplify app.go wiring, because modules then would sort of just send messages to other modules without needing to receive a direct reference to the module, which is what currently happens in app.go. So we see a pathway forward to greatly simplifying that. And like I was saying, authorization is automatically handled with this model. And the basic idea is that every module has their own address, is their own kind of identity. And if you're sending a message to another module, the module can check, is this address authorized to send this message or not? And it's the basic way that if a client is sending something to the blockchain, the blockchain needs to verify, hey, did the client with this public key sign the message? And if not, they can't perform that transaction. So applying that same sort of model to intermodule communication could open up some interesting things, such as like modules that are fully implemented in WASM using Cosmos WASM, or some other ways we could have modules in other languages. So there's lots of interesting things that could be opened up by this approach. Let's see. And so goals for app developers, this is mainly around just making it really easy to compose modules in app.go, making them much more concise. And so, we have the idea, and I think a lot of people have the idea that Cosmos SDK should make building a blockchain from existing modules really simple. So, what if we had something that was just as simple as, just choose the modules, put a few settings in there, and then compose that together into an app and start it. And so this example here is definitely oversimplified, but it just kind of gives you the gist of what we're thinking about, which is a much more just declarative approach of like, these modules need this configuration. And then when you start the app at initialization, they will wire up their dependencies, and all that stuff should get taken care of without an app developer needing to think too much about, did they pass the store key in correctly and register the store key with the store? There's a lot of just different things that it's hard to get right with the current system that we think we could improve on greatly for 1.0. Another idea that we have is that maybe we can have independently versioned modules. Like maybe we could split up the base and core packages like types and base app and bank and gov and other modules into separate Go modules, maybe within the same repo, maybe eventually in different repositories. And this could lead us to a scenario where each module could have its own version and own release cycle, so that we're not as kind of, everything is not tied to like Cosmos SDK releases as a whole big project, but sort of more smaller pieces with a bit of their own development cycle. We're not quite clear on how we would go about this. If it's, just, can we split things up into separate Go modules, and is that desirable? There have been on and off questions about separate repos. Currently, it feels like we're for the time being, we're going to stick with one repo, but there's things, maybe some improvements we can make there. So that's basically what I have for the presentation. I'd like to open up to comments and questions. I posted this GitHub issue here, 7421. If you go visit our GitHub issues, you can just find it pinned at the top. And we hope this roadmap brings us one step closer to realizing the Cosmos vision. Thank you for your time. And now I'll go check and see what questions there are. Let's see. I see a bunch of stuff. Is there a separate Q&A tool here? I'm not ask a question. Is the Cosmos SDK still all in on the capability-based security module? Yeah, I mean, I think the idea that I've been presenting here with this intermodule communication is that this is a way of sort of like object capabilities. Maybe it's not strictly, maybe that's not quite the right term for this approach, but the idea is that each module would have its own identity, and the very basic authorization check is if you're sending a message, say I'm sending coins, if the module kind of would sort of be able to sign a message sending coins from its own module account to another account, and there could be other different authorization layers where we could have some modules be admin modules for certain, like have admin permissions over certain operations, or certain operations under certain conditions. And so that would be sort of like how we're approaching OCAPs. And I think the answer is this approach is yes, all in sort of in terms of a capability-based security module. So another question is, what is the status of IAVL maintainership? So yeah, I mean, that's a bit of a, yeah, I'm not quite sure what to say. We did have a discussion about Regen taking over IAVL maintainership at one point, but we had one of our engineers actually just do a bit of research around the different alternatives to IAVL, like what is the cutting edge in terms of Merkle trees, and at least where the last time we kind of had that conversation, we were considering using a project SMT from Lazy Ledger and as a potential alternative to IAVL. So there definitely needs to be a conversation in the near future, sometime in 2021, about do we stick with IAVL, or do we consider swapping it out for something else like SMT from Lazy Ledger? So another question here is, will it be possible to swap out protobuf for another encoding scheme? I mean, I think it's yes and no. I think the way the SDK is currently designed, it's sort of all in on protobuf. You still can enable amino mode, and amino serialization still should mostly work. But the last time I tried it, there were some subtle bugs, and we're not actually testing a full amino compatible version. Could you use something else? Like at one point we'd explored Cap and Proto. Yeah, I think it would require some work. It's not super easy. And so this next question is there a plan to separate out maintenance of the SDK, separate out maintenance of the SDK from core-ish modules, i.e. staking, gov, distribution, but not auth and params? Yes, we have been, I wouldn't say there's a plan, but there have been discussions about, maybe some group is going to take on staking. Maybe staking goes with the Gaia maintainer, or yeah, there have been some discussions. Nothing conclusive, but something we're talking about. Let's see. Yeah, and I guess we're about at the top of the hour. So yeah, thank you all for tuning in.